My name is Thomas Larock, and joining me is John Potokny. Say hello, John.
Thanks, Tom. I'm a technical advisor for SolarWinds. My specialty is database products, so I help with the sales process for DPA and DPM, as well as providing product feedback and bug reports for the engineering teams.
And tell us a little bit about your background.
I've been a back-end engineer developing applications against databases for time series monitoring and data management for about 5 years before I switched over to being a technical advisor for SolarWinds.
And so for me, I think some of the audience would know I'm a former database administrator, before that programmer analyst, and my background is a lot of heavy SQL Server, traditional relational database systems. But I think, and the key point for this entire session is how the nature of applications have changed over time. A lot of the apps that I would have to administer would be what I would call legacy apps. We're talking single node in your own data center, and that's it, right? Maybe a failover instance somewhere else, but it would not be what I would call a modern app, which would be something that might be globally distributed. And it seems to me that you have a little more experience with that type of, say, databases that are built for a global distribution, or, well, sometimes use the word cloud native. Part of the driving force for this episode is to talk about how a lot of the tools and systems and scripts that we have were built for maybe kind of a different type of system and workload.
Yeah, absolutely. Comparing from the legacy model of having maybe one application, one server even, to these days where you can have dozens of systems that are interacting together to form a single application that a user interacts with. It's quite a big shift in terms of both complexity and how it's being run and where it's located, right? Going from on-premise data centers to running out of cloud data centers like Amazon or Azure.
The heavy hitters in the cloud space are certainly those two. And they're helping drive kind of the shift as well. Those traditional relational systems aren't going anywhere. They still exist. But what I see is that those systems are now giving you opportunities to build globally distributed systems still using even the relational model. I see a lot of blending between what I would call NoSQL and SQL systems. So you have these database platforms that are now called multi-model, and they can pretty much do just about anything you need them to do. I know Postgres is on the rise, right? We know PostgreSQL is taking on more and more market share. Do you think it'll ever overtake a Microsoft or an Oracle?
I'm inclined to say yes. Postgres is definitely, one of the databases that I'm far more familiar with and far more comfortable with. And it has the advantage of being free and open source, whereas you have to pay for a license with SQL Server and Oracle. That's not to say that SQL Server and Oracle are going to be gone next year even, but it does seem to be the way that the landscape is trending, right? As you said, Postgres is becoming more and more popular every single year, as well as other open source databases like MySQL and MongoDB or Cassandra.
In your world of Postgres and where you're coming from and with your experience and background, are you seeing that database administrators on an ongoing basis are simply asked to monitor more databases than in some cases can even be realistic?
Absolutely. If you don't have good tooling and good automation in place, having one person monitor dozens, hundreds of databases, which is what we frequently see when we're dealing with our customers, is quite frankly unreasonable. You can't have somebody going and watching 300 different databases day in and day out. They need tooling in place to do it for them. And it's really kind of changed the conversation of what the problems that our customers are facing look like. Instead of having, maybe a couple of command line tools that you can use to keep tabs on a system, you need to have systems that are monitoring everything in a data center or everything in multiple data centers simultaneously and giving you real-time intelligence on what's going on.
That's one of the reasons we built a feature into DPA we call Anomaly Detection. And enough chat. Why don't we just dive in and take a look at the demo for a second?
Yeah, absolutely.
So this is the main page for DPA, for Database Performance Analyzer. And the first thing I always like to point out is the support we have for a variety of database platforms. So you've got your SQL Server, you've got your Oracle, your DB2, the artist formerly known as Sybase. We've also added in the past few years, MySQL and PostgreSQL, right? So that alone shows the breadth of platforms we have support for. And this is a good and bad thing, because when the finance team now goes off and they buy themselves a brand new application and its back end, say, is Postgres, well, they're going to expect the DBA to help them with performance tuning and monitoring. So DPA gives you that ability to do that because it's just the one tool that can do all these different platforms. That sounds great, but that also means your workload as a DBA can increase, sometimes exponentially. So you could end up with dozens or hundreds or even 1,000 systems that you might be responsible for. That's going to lead to a lot of noise. So within the past, I say 2 years, we've built out this feature that we call Anomaly Detection. So when you're looking at this main page for SQL Server, and in this wait column, you can see that I have this yellow bar. So there's a warning on anomaly, and that's going to draw my attention. So if you can imagine this dashboard was filled with all different green bars, it's that yellow or red one I'm going to want to focus on. So with one click, it drills me into that particular day, a 24-hour period on top, and then a correlating 24 hours in the bottom of anomaly detection. And what made me really excited about this feature is that it's not just a baseline. It's not just rules-based, and it's not just saying, hey, something was different than yesterday. No. These are predictions. There's actual math here. There's real machine learning that's happening. We build a prediction. We say, this is how much weight we should have in the 11 a.m. hour. And then when the weight gets recorded as something more than that, and if it's more than 3 standard deviations away, we say, whoa, that's critical. Now that is the signal through the noise. You're going to want to pay attention to what's happening here. And usually with DPA, we used to tell people the bigger bar is where you want to focus, because this is a sum of all executions. This is the sum of weight across all executions for all these different statements. And you add that up and it's an aggregate, and it shows you how much for that particular hour time slice. But it wasn't an anomaly, right? We were actually expecting a big workload at 2 p.m. At 11 a.m., we weren't expecting that. That's where I'm going to want to focus. So the ability for DPA to kind of bring it together and get you that signal through the noise, I think has an incredible amount of value for any database professional, because now you're going to be able to say, I need to focus on this particular thing. I need to take action possibly, and this is where I need to go. Yeah. Without that, I think it's going to be kind of overwhelming.
Yeah, this is great. If you've got 300 databases that you're responsible for, I don't have to spend my time combing through each one and worrying about missing the one that's going to have the problem. I can just wait until the anomaly detection alerts me to a problem and focus on where the issues actually lie in my infrastructure. When we talk about being responsible for infrastructure, especially looking at kind of these new stack environments where we have many different services interacting with shared database layers as well, there's kind of another aspect to monitoring database performance that I run into a lot with customers, and that is being able to understand as a service owner or a service expert how my service is interacting with the database specifically, right? If I'm the engineer who's writing a particular application that is one of many talking to a given database or a set of databases, I don't really care about the others. I only care about the one that I'm actively developing on. And so there's a problem where we have to be able to not just understand what's going on with the database, but also be able to relate, how are my different apps interacting with this database that I'm responsible for too? And there's a feature in DPM that allows us to really cut through and see, what app is responsible for the traffic that we're seeing. So this is Database Performance Monitor, DPM. Similar to DPA, it does support a number of different database types. So we handle MySQL, Postgres, MongoDB, and Redis as well. And of course, any cloud environments. If you're in Amazon, we can handle RDS and Aurora. If you're running in Azure or Google Cloud Platform, that works too. And one of the nice things about DPM is by default, it's going to give you a holistic view of what's going on in your data center. So right now I'm looking at DPM's profiler, and we're showing the top 20 most time-consuming queries. This is across all my databases at once. So I've got 53 different servers that I'm monitoring here, and we can see across all of them what is driving the workload for my whole data layer. And if I want to get a sense of what's going on with a particular query that I see in my list here, I can just go ahead and click on it and get some details about which servers in my data center are running this query and how much each one is contributing towards the total traffic that we see. Something really nice about this view as well is it's going to show me information about where this query is coming from. In particular, this tag section that you see here is giving me some breadcrumbs about what users, what databases, or in this case, what application is running this particular query. So this app equals guestbook tag is something that I can use to filter my view when I'm looking at the profiler from the previous page. We go back up and expand the filter bar here. I can take that tag and get all the queries that have similar application running it. And so now we're looking at an application-centric view of what's going on across all my databases. And if I'm the guestbook maintainer, this is going to be incredibly valuable for me to understand what my system is doing to my databases, as well as help identify bottlenecks that are specific to my service, right? The DBA is going to care about holistically, is the database healthy? What does this workload look like? But an engineer may want to look at this view specifically so that they can make sure that they have the best performance for their service and not look at queries that are from other services that they're not responsible for. And so when we have many different services and many different teams that are accessing a shared infrastructure and developing multiple applications simultaneously, this gives us the ability to show everyone exactly what they need to see and not have noise cluttering their view that isn't actually relevant to what they need to look at.
I really like the use of tags. Of course, tags gives me that whole DevOpsy feel. So, you could even think about this in terms of putting out some sort of tied to a change control, and you need to roll something back, or you just need to observe a particular change that you were putting out there. And this is great, but I think one aspect that we want to consider is it's not enough to just know something is slow. When you're going to go fix it, what if you got to have a way to understand what's going to be the impact of the change that you're going to make? And there's a way that we do that in DPA. And let me take a minute to show you how that gets done.
Yeah, absolutely.
So we're back at the home screen for DPA here. And what you're seeing is we're going to focus on that tuning column this time, right? So notice it says a table tuning advisor alarm. So historically, DPA, and we still do this, we collect information upon the query statements that are running, and we might highlight those and say, here's the top 3 or 5 queries you might want to look at. But what we've added recently is this concept of a table tuning advisor. So I'm going to click on this critical tuning advisor. And now what you're seeing is that here are the query advisors on the left that we've had historically. But on the right now, you have this idea of a table tuning advisor. And we're going to look at line item. And this is what I'm talking about. So there's 72 queries hitting that line item table that may benefit from tuning. And there are 4 index recommendations. So in my career, at least once, I've made a change to an index in order to help tune one particular query. And I pat myself on the back because all of a sudden I'm like, that query is going great now. And then you realize you may have made 10 queries worse because more than one query is using that index in the course of a day, week, month, year, right? So you have this balance and you have to figure out, hey, if I'm going to make this change, and what's that change going to be, right? So if you click through, you get more information upon the table itself. This is what I like, right? The table tuning best practices. A lot of people that end up using a tool like DPA may not be necessarily a database administrator. They might be a developer, but they might need a little help and guidance in database design. So little things that can help you, right? So in this case, we have a wide index. We have some overlapping indexes. The table doesn't have a primary key. The foreign key is not indexed. These are all things that you can do in order to help performance for this particular table. So what we've done is we take a lot of the standard data that you can get from the internet. You can find some script somewhere, you can run it, it can show you missing indexes, this, that, and the other. But what we have is we've taken a slight pivot and we say, all right, take that knowledge and now think about it in a slightly different way. Think about it as a table or an index level, and think about the impact of the change you're going to have by altering that one index. And being able to show you that information here in DPA actually is going to make you a lot more effective, right? So we get that signal through the noise, and this is the particular signal that comes through. And now you get it and say, whoa, I can't just make that change. It might make things worse. Or yes, I can do something about that in a fairly short amount of time. It's not going to impact anybody else.
Yeah, this works really well when you're doing table design. If you are trying to understand what the best indexes for your workload are, then you've got one view that'll help you see everything that's running against that table. And you can take a look and see, okay, when I add this index, which queries benefit, which queries might suffer. It's a great way to help with being able to understand exactly why your schema might be underperforming and find the where you can improve. A lot of the changes that people make that are going to impact their database, though, it's not going to be adding or removing an index or even doing alter tables on the schema. Everyday changes that are being made by developers that never directly interact with the database can have huge impacts on what's going on with overall performance. And so something we do in DPM is making it easy for those developers that might have no clue how indexing and table design works for the system. If they just have an ORM that they are interacting with and it's going to generate queries for them, they still need to know if they have done something that is going to introduce a negative impact. And so we help make sure that they can take a look after they have made a change to their application and see what that did to the database performance. Back over in DPM, looking at the profiler, if I'm somebody who's just introduced a change for the guestbook app, and I need to understand how performance has changed after that new version has been deployed, there are a few different tools that we can take advantage of to help us understand exactly what happened from the database's perspective. First thing I'm going to do is over in the top right-hand corner, I can overlay change markers that tell me when different things have happened. We capture a lot of stuff out of the box for database configuration changes and whatnot, but you can also send your own. So I've got a change marker in here that tells me when my last app deployment for the guestbook app was. So this dashed line that shows up now tells me exactly when the last deploy occurred, right at the top of the hour. And we can click and drag to zoom and get the time frame right after that deployment was introduced. And from here, we can compare and look at what performance looked like right before that deploy happened. So let's look at 1 hour in the past compared to right after the deploy. And now we're getting the before and after view of my query workload for the guestbook app. And you'll notice you can see the behavior for each query. On top is the most recent time frame. Down below is 1 hour in the past. And we also get this nice change column that pops up on the side and will help me quickly identify if a query has a big relative shift in behavior. So I'm just going to click and sort by biggest changes. And here we go. We can see that there's a query that's got a 1,261% increase in time spent running. So if I've just introduced a change that could have affected the guestbook app, I might want to take a look at what I did, because this looks like something that I may not have expected to have happen. I might want to revert my change, take a closer look at what it did, and make sure I didn't introduce a problem.
I like how it's really easy for you to use these tags and to quickly identify and filter and sort in order to understand the impact of the change there. I just think it's wonderful.
Yeah. There's one other thing that we can do as well for understanding new features that are being introduced too. I'm sure you've probably run into a case where you've seen a new query that pops up that isn't using an index, and it can totally destroy database performance.
Mm-hmm.
But it's not always obvious when a new query gets introduced if it's related to a feature that isn't being used yet. And so DPM will let us track and find those queries that are introduced and help you keep track of which ones are taking advantage of indexes correctly versus ones that might be missing an index we need to review a little more closely. Outside of the profiler on our queries page, I can filter and find queries based on their content, based on their behavior. So I'll filter to missing indexes. And I can also look for queries that are new. So have been seen for the first time by DPM in the time frame I'm looking at. And here's a query that lines up right with my deployment that's missing an index. I might want to take another look at this, get my DBA involved if I'm just a developer that might not understand the table design for this part of the application, and make sure that there's nothing we can do to make this better. If this table is expected to grow over time, then this could be a performance problem waiting to happen.
What, a developer doesn't understand database design, you say?
You'd be surprised. Yep, it lets the entire team make sure that they're helping to own performance instead of having the one or two DBAs that are responsible for those hundreds of databases. It's now a group effort instead of an isolated couple of individuals that are responsible for it all.
That's great. So John, I really like DPM because to me it's a tool that is really built to monitor those distributed systems that are, say, a little more modern, say built a little more recently than those legacy applications. And a legacy app doesn't necessarily mean it has to be, the traditional relational database. Like a legacy app could be a MySQL app. It's just that there's a different way you want to approach how you want to monitor and performance tune these types of systems. And I think the best way of putting it, how recently I've been trying to tell people, is you want to tune the workload and not queries. You want to focus on tuning the workload, not necessarily just one specific query. And for DPM, I look at DPM and I think this is a great tool if I was really going to be somebody that was focused on those 4 golden signals. And I think that's something that you agree with.
Yeah, 100%. I like to contrast to what we showed in DPA, right? The table tuning advisors and the anomaly detection, they are really powerful tools for helping an expert analyze and be efficient in optimizing the database from an architectural perspective. If you have many different applications and many different workloads that are interacting with the shared data layer, though, you might want some of the features in a tool like DPM to help everyone get their particular view of the workload that they need to focus on and optimize.
Absolutely, I couldn't agree more. That's what the decision you have to make is, what world are you living in? Sometimes you live in both worlds, but you might only live in one. And so this is kind of where we try to guide people to help them understand which tool is going to be right for them.
Yeah.
So, John, thank you for joining me here today. It was great having you. We should do this again sometime.
Yeah, thanks for having me. Happy to do it anytime.
Great. And once again, John Potokny, Thomas LaRock, and thanks for joining us.